All right, well, good morning and happy Monday. I hope you all had a good weekend. Um, we are moving right along, week 3. So midterms are already starting up, I guess. Maybe. All right. Well, anyway, we'll take a look at what we have. So today we are going to look at dictionaries, and so dictionaries, um, in my opinion, are super exciting. I don't know about super exciting, but they're really great. And a lot of things in Python are powered by dictionaries. Python does dictionaries really, really, really well. Okay. And so dictionaries, they are a data structure, kind of like a list, but also at the same time, not at all like a list. So a list is indexed by position. So if you think of a grocery list or a to-do list or something, it's kind of like, what's the first item on your list? What's the second item on your list? So on and so forth. And that's how we reference items in a list is we say, hey, give me index position 0, index position 1, index position, so on and so forth. A dictionary, on the other hand, does not have is not ordered, doesn't have an inherent order. But we reference all of the items in the dictionary by what we call a key. So dictionaries consists of key value pairs. So you have a key, and then you have a value associated with that key. Okay, and so all the keys have to be unique. You can't have duplicate keys inside a dictionary. Um, the values, they can be whatever, okay, but the keys have to be um, unique, and they have to be what we call hashable. All right, and so the most common way you will create a dictionary is a curly brace. All right, and so anytime you see curly braces, that means we are creating a brand new dictionary. Right, much in the same way that in when we were talking about lists, anytime you see the square brackets, we are creating a list. Okay, so I guess when it's kind of like leading, right? So we're creating a new list with the square brackets. We create new dictionaries with curly braces, and inside you have everything's in the form of key along with value. And so this is, we're going to pretend this is a dictionary of people. We've got Adam and then just their fictional ages, fictional people and their ages. So we got Adam 25, Bob has value 19, Key Carl has value 30. Okay, and that's going to be people. And then you can ask Python to print out people, and it prints out the dictionary. Okay, if your keys are simple strings, you can kind of create a. You can also create a dictionary using the function dict, okay? And what this does is it tries to coerce whatever's inside into a dictionary, right? And so if it's something like this, you just have some objects named. So I have Adam is equal to 25, Bob equal to 19, Carl equal to 30. Then this is going to be another dictionary. All right, so here's a question. Is people and people two, are these the same object or are they different objects? They're different objects, right? Because I created a dictionary up here, okay, and then I created a separate dictionary over here. Even though the kind of the entries and the contents of them are we have the same keys and the same values, they are definitely different objects. And so, like if I say ID of people, I get this number, and if I say ID of people two, I get a different number. I can ask, is ID is people? I'm sorry, not ID. People is people two, and that's going to come back as false. Actually, I don't know if I can do this. Is people equal to people two? I'm not sure. Okay, so the contents, yeah. So I am allowed to do this. The contents of the people dictionary and the people two dictionary are equivalent, okay, but they are different they are different objects, okay? All right, we have other ways to create a dictionary. So like this is a very kind of manual way, typing it out like this. Okay, that's a very manual way of creating a dictionary. You can do that for like simple dictionaries that aren't super long. You can just kind of manually type things out. But probably most often, if you're going to create a dictionary, you're going to use, you know, one of these tools or something like this. Okay, and so we have, so you might have like 2 lists or something, and here I typed out these lists. But perhaps more common is you'll import a data file and then you'll extract out one of the columns or something like that, okay? And so, but you can imagine you have some kind of list-like structure, okay? And you might have 2 of them and you want to kind of match them up. So here I have 2 lists, and what I want to do is I want to match up the names over here, which will be our keys, to the values over here. So I have a list of names, I have a list of integers or ages, and I want to kind of bring them together. And so what zip does, okay, again, it's like the idea of a zipper, and it's basically you've got these 2 things, and you're going to take one from this side and one from this side and bring them together. One from this side, one from this side, bring them together. And so it just does it respectively, is that the right word? Where we're just going to match the first with the first, the second with the second, so on and so forth. Okay, but again, Python is lazy. So when you call zip and you say, I want you to zip these 2 lists together, Python's like, yep, I understand what you want, but it doesn't do it, okay? It doesn't do it until it's forced to. So when you say, zip these 2 together, Python goes, okay, I've got it. I'll zip it. I'll zip them together. Have you done it? No, not yet, okay? But I'll do it. I'll do it when you want me to do it. Okay, it's kind of like I don't know if you've ever had to manage somebody or something, right? Like maybe on a group project, it's like, are you going to do that thing? Yeah, I'll do it. I'll do it. I'll do it when I need to. Okay, and so it just says, yep, I've got a zip. I understand. You want me to zip this thing together. I'll do it when you want me to do it. Okay. If you want to kind of force it and say, no, don't tell me you're going to just zip it. I want you to actually make the dictionary, because what I want is the dictionary. You can take the zip object and put it inside the function dict. And what that will do is, again, it tries to kind of force whatever's inside into a dictionary. And so this will actually create the dictionary. All right. So it says, okay, fine. If you want the dictionary, there it is. And you have the dictionary right there. Okay. And again, if I say people is people3, it's going to be no, because this is an entirely new thing. But I think I use the same values in there. So is people equivalent in value to people3? And that's true. Okay. So again, there is a distinction between is and equal, right? Okay. Another way you can do this is here I've got a bunch of kind of tuples. It could be lists as well. So if you have a bunch of kind of, so this is you'll notice the structure is a list of tuples, but it could also be a list of lists. Okay, I can even change this first one to a list. Okay, so I've got a list containing a list, a tuple, and a tuple. All right, and all of these are two items where the first is the key and the second is the value, and it coerces it into a dictionary. Okay, so this is another kind of way. If you have a list of lists or a list of tuples, where each tuple is of length 2, it's going to take the first one and set it as the key, and then take the second value and set it as the value. Okay, so I think people4 is equivalent, not the same object as people, but equivalent to people. So if you want to kind of get any of the values, access any of the values in the dictionary, you reference them using the key. So you use square bracket, kind of like you're subsetting the list, but here we're accessing the value associated with the key Bob. Okay, so if you do this and you say, hey, what is the value associated with the key Bob? It comes back 19. Okay, you can also use the method get. Okay. And you can do people.get Bob, and this will also give you back 19. So you might wonder, like, okay, what's the difference? What's the difference between the square bracket and the dot get? Okay, if you give it a key that doesn't exist and you use square bracket, you get back an error. Okay, this will error out, and you get what's a key error. Basically, it says the key you've provided causes an error. Is what it says, right? But if you say people.get, okay, people.get, and you give it something that doesn't exist, it will return none. Normally, if I just do people.get this, okay, the output of none usually doesn't show, okay? So if I just do people.get Joe, usually it's returning none, so it like doesn't actually spit anything out to the screen. If you force it to print what it returned, it will print none, okay? But there's a difference there, right? Okay, and then you can also put in a default value, okay? So if you say people.get Joe, and if you can't find it, and you say, well, I want something, okay, you can say I want a 0 back or something, you know, whatever it wants. But we want to be careful about arbitrary values being returned, and we have to ask ourselves, does it make sense, right? So for example, if you're like, what's the average age of these people, okay? And then you have a bunch of people that don't exist. Now you have a whole bunch of zeros getting computed into your average, and that's going to mess things up probably, okay? So in some cases it makes sense to do that. In other cases it does not. Okay, as far as the values go, the values can be anything, okay? As far as the keys go, however, the keys have to be what we call immutable objects, right? So examples of things that are immutable are strings, numbers, tuples, which we haven't really gotten into the details on tuples, but they're kind of like lists, but they're created with curly braces. Not curly braces, sorry. Curved braces or parentheses. Okay, I don't. What do we call these things? We call these parentheses. So square brackets. It's like curly brackets, square bracket, or curly braces. I don't know. And then curved or parentheses. Okay, so tuples are created with parentheses, and they are immutable. They look like lists, but they are immutable. Like a list, you can append objects and modify the object in memory. Tuples, you cannot. And there's an advantage to that in that they become immutable and they can be used as keys in dictionary. Okay, you could even use functions as a key, which feels weird, but it is possible. Okay, dictionaries are not allowed to have duplicate keys, and so anyway, here is an example. I'm creating a dictionary. The keys are the integers 1, 3, 4, 2. Okay. The value associated with what the key is for one is the length function. Here I've got a dictionary as the value. Here I have a tuple, and here I have a list. Okay. When Python reads, it reads left to right. Okay. So here I've got this. I can say, hey, what is D? D gives you back the function length. D2. Okay, and again, this is we are calling by key, not index position. Okay, it feels like it's index position, but it's a key. Okay, and so you have to kind of think of a dictionary. It's unordered. You only reference things by name. Okay, so it's kind of like, you know, a list. You have the first item on the list, second item on the list, third item on the list. A dictionary, you kind of have to think of like objects in your backpack. Okay, there's no, like if I say give me object number 3 in your backpack, that's a confusing request because what is the third object? But if I say, hey, you know, I don't know, maybe everything in your backpack has a name, but there's a way to reference everything in your backpack, right? You can say, okay, pull out your, I don't know, math textbook or something, right? Pull out a water bottle. And so with a dictionary, we can say, pull out value associated with key 1. Okay, pull out value associated with key 2, value associated with key 3, value associated with key 4, right? And we can have any kind of object there. Okay. before I forget. First answer today is the letter A. A as in apple. A as in apple. The keys in a dictionary have to be immutable, which allows them to be hashable. Okay, so things like a list or other dictionaries are mutable objects, meaning that they can exist in memory, and that object in memory can be changed. So, like with a list, you can append objects to that thing, right? You're not creating a new list containing the same entries. You're taking the actual list, that whatever that thing is, and you're appending things to it. Okay. So here I've got a list containing values 1 and 2, and then here I have T, which is a tuple. Okay, and the only difference is list is created with square brackets and tuple is created with parentheses. But the list is mutable, the tuple is immutable, and the tuple can be used as a dictionary key. So, so here I'm going to create an empty dictionary, and with a dictionary you can assign new entries. So, actually, I never actually did this here. Okay, so prior to this, like I can take, I can take the dictionary and I can just say like key 1, and then we can set it equal to like the number 5. Okay, and then so if I ask, you can set new entries in your dictionary like this. Okay, and that's fine because key 1 is a string and that's immutable, right? If I try to take the list and use that as a key to assign it, I'm going to get back an error. Okay, this is it. I get back a type error, and it says the list is unhashable. Okay. On the other hand, if I take the tuple, I can use that as a key, and I can assign a value to that key. Okay, so here I'm going to get D of this, and then so if I print out what D is now, we've got 2 keys in there. We've got key 1, which is associated with the value 5, and then here I have the tuple 1, 2, all right, and that's associated with the value this is okay, all right. And you might feel like, why would you ever want a tuple as a key? I'll show you an example where it kind of makes sense, and then you realize like, oh, actually, could be a useful way, right? Okay, so as far as like if you create a dictionary and you put in duplicate keys, okay, Python doesn't allow duplicate keys. What it does is, it reads left to right. So anytime it sees a new value associated with a key, it updates the value. Okay, so as it's reading left to right, it says, okay, we're creating a new dictionary. All right, first I've got the key and I'm putting the value 1. I've got the key A gets the value 1. Key B gets the value 10. Oh, key A again. All right, let's update that to value 2. Key B again. Oh, okay, let's update that to value 0. Oh, key A again. Let's update that to value 3. So at the end, your dictionary is going to have A with value 3 and B with value 0. Okay, so that's what we have. Okay, so it's not going to create a duplicate A or a B key. It just says anytime it encounters a new value for that thing, it just updates the thing. Okay, reading left to right. Okay, so yeah, so what is the value B associated with B? 0. What's the value associated with A? Is 3. That's what we have. Okay. All right, here is my people dictionary from earlier. Dictionaries are not indexed by position. So again, if I say, hey, give me the third object in your backpack, it's confusing, and dictionaries will get confused as well. All right, so if you say, hey, give me index position 0, it says no. Okay, it says that's a key error. You gave me basically it says the 0 you gave me is a key, and I don't know what that is. Okay, and similarly with because slicing relies on position, you can't slice a dictionary. You can't say, give me the third through the fifth object in your backpack. Okay, that doesn't make sense, right? And I can't say, okay, give me in your backpack, give me the objects between math textbook and water bottle, because what's the order in the thing? So so anyway, so here's our people dictionary. You can't slice. Okay, you can't slice a dictionary. You can't slice based on position. You can't slice based on names. Okay, because you can't, like, we look at this and we might think like, oh, okay, the order of these things is this, but this is just an arbitrary ordering of the objects in the dictionary. There's no inherent order to this. Okay. If you want to see if an entry exists inside a dictionary, okay, or if a key exists, you use the operator in, right, and this will return a true or false. Is Adam a key inside people? That's going to be yes. Okay. If you want to check for values, you have to use the dictionary name dot values. Okay. If I do 19 in people, okay, 19 is going to return false because it's looking for 19 as a key. Okay. But 19 is a value. And so if you want to say, hey, is 19 one of the values, you can do people dot values. 19 in people dot values is that's going to be true. Okay. One of the things that really makes dictionaries super powerful is the fact that all of the entries in the dictionary have to have hashable keys. And like behind the scenes, I don't actually know what's happening, but the dictionary has what's called a hash table, and when you use this in operator, it is very, very, very fast, or it basically works the same speed for dictionaries of any size. Okay, so you could have, if you might have a dictionary of like 80,000 keys, okay, and you can say, hey, check to see if, I don't know, the key abracadabra is in there, okay, and it checks it in just basically one operation. Okay. Meanwhile, if you have a list and you say check to see if something is in the list, because you can use in for a list as well. You can say, is 19 a value inside the list? The way Python checks for values in a list is it reads through the list basically left to right, top to bottom. Okay, so it just goes and it says, okay, is 19 is like the first value 19, is the second value 19, third value 19, fourth value 19, and if you have a list that's 80,000 entries long, it takes a really long time for Python to find the list or find the item in the list. Okay, because in memory, the way the Python list data structure is, because lists can have all kinds of different data types. You can mix integers with doubles with Boolean values and strings and stuff. It actually consumes a lot of space, and it, I don't know, it takes a while to figure out. Okay, dictionaries also consume a lot of space in memory, but it creates this hash table, and you can check to see if a value exists in the key very quickly, right? And so, in fact, sometimes the application of a dictionary is for that speed, and you basically want to create a list, and you don't actually need the key value pair, but you do want the speed associated with a dictionary as far as looking things up. And so sometimes you'll create a dictionary where you just take like this huge list of stuff and you just say make keys out of everything in that list. And then as far as the value goes, just associate it with the value 0. Okay, because I actually don't care about the value. I just want to have all of these entries that are currently in a list, and I want to turn it into a dictionary structure And then when it's a dictionary structure, you get the advantages of the speed computation. Okay. All right. So what did I say? Python dictionaries use a data structure called a hash table. The in operator takes about the same amount of time no matter how many items in the dictionary, right? And so that's actually a really nice feature. Okay. All right. Let's say you want to modify dictionary entries. So here's my my current people dictionary. All right. We can just create new entries. Okay. So I can just give it a new key that's not part of it, and I give it a new value, and that's going to create a new entry. I can take an existing key and I can change the value. Okay. And then so now our dictionary gets updated. Okay. If you want to get rid of something in the dictionary, you can use del, okay, for delete. So if we want to delete Carl as an entry, as one of the keys in there, we just do that, okay, and then it's gone, okay. And we have that, okay. We have pop. Pop basically removes an entry from the dictionary and returns that value. Okay. Again, with a list, you also have list.pop, and if you don't provide an index in the list, it defaults to the last item in the dictionary. Dictionaries are unordered, so we don't have a last entry. So you can't run pop without anything, but you provide pop with the key that you want to pop. This will return the value and delete that entry from the dictionary, okay? So it says, okay, the value associated with Adam is 26, and we've updated the dictionary so that Adam is no longer an entry in the dictionary, okay? If you have another dictionary, you can use .update, and it will basically take the second dictionary and update the current dictionary with whatever values appear in the second dictionary, okay? So as far as like if you want to kind of merge or join two dictionaries together, you use update, right? You can't just do a plus. You can't do a plus. And the reason why you can't do a plus is you can't have duplicate entries in a dictionary, right? And so what if I have two dictionaries that both have the key Adam, okay? And if I do dictionary 1 plus dictionary 2, which one do I keep and which one do I get rid of, okay? And so plus is kind of like a commutative operation, is that what we say? Where like the order of addition doesn't matter, okay? So we don't want to say that. We want to say we're going to take dictionary 1 and update it with dictionary 2. That implies that dictionary 2 has the newer entries, and they should overwrite any of the entries in dictionary 1, okay? You know, or if you reverse that, dictionary 2 should get updated with the values in dictionary 1. That implies the one that we're using, dictionary 1, has the updated values or something, right? So you use dictionary.update, it will go look at the other dictionary. If they're all new keys, no problem, okay? It's going to take all of these things, and it's like adding these keys together. So I have people A and I have people B. I'm going to say take people A and update it with the entries in people B, okay? And so people A gets modified, and now we've got, I just tried to look for generic alphabet names, okay? So now we have, you know, A, B, C, D, E, and F, okay? If we have, again, with dictionary.update, we're going to assume, not assume, but it's going to say take the existing dictionary and update it with whatever we have in this new dictionary. So here I've got people C, we have entry Fred, or key Fred, and inside people C we have key Fred. And we're going to say, hey, take whatever's in people A, update it with whatever you see in people C. And so this 99 is going to overwrite people A there. Okay, so people A And I guess the dictionary is long enough that it now prints it vertically, but now Fred has been updated to be 99. Okay. So that's what we have. Okay, let me give you answer number 2, which is E. E as an elephant. E as an elephant is answer number 2. Okay, dictionaries have what we call dynamic view objects, right? And so once you create a view object, the view object is associated with the dictionary, and whenever the dictionary updates, the corresponding view object also updates. Okay, it's a little bit weird to think about, but when you create a view object, it's basically kind of like a I don't know, like a viewer, right? You're kind of like looking at the object. It's like a way to kind of see what it is. So whenever the dictionary gets updated, the view gets updated, right? It's not the same thing as I'll show you in a moment. Like you can take the view object and you can take a picture of it, okay? And if you take a picture of it, that thing is not going to get updated, okay? But the view object itself does get updated. All right, and so the view objects are dictionary.keys, dictionary.values, and dictionary.items. And items are the key value pairs, the combinations of the key value things. All right, so again, here I'm creating a brand new dictionary, Adam, Bob, and Carl. Okay, and so this is my dictionary. I can say the names, people.keys, ages will be people.values. Okay, names are the view object associated with the keys. Okay, and so this will be Adam, Bob, and Carl, and it will say dictionary keys. It looks kind of like a list, but it's not a list. It is a view object. Okay, ages are this. Okay, so with a view object, if this is a viewer, you can't like mess around with the object through the viewer. Okay, because it's a viewer, right? So, but anyway, so here I'm going to update the dictionary. I'm going to add entry ed 40, okay? And notice I haven't redefined names, okay? And I can just say, hey, what is names now? Names will now have Adam, Bob, Carl, and Ed, okay? It's this, right? I can go and ask what are the ages, right? And these have updated without doing anything. The view objects only support really a couple things, okay? Length and in, okay? You can say, hey, what's the length? This automatically gets updated, right? Is in one of the thing? Is 35 one of the values in ages? And the answer is going to be no, okay? Now, if you want to kind of like do more stuff with it, you can take this view object and you can force it into a list. And this is kind of like taking a picture out of your viewer, right? You're taking a picture out of your viewer. But now this thing is an entirely separate thing. It's a list, and it's no longer associated with the dictionary, right? So here's just the list of all of these things. And so, I can add a new key value pair in the dictionary. I can say, hey, let's add Frank 29, okay? And if I take ages, ages being the viewer, I can say, all right, let's look at the view object. It now has the new entry 29, okay? Does age list have this new entry? No, okay, because you took a picture, right? You basically took a snapshot of the dictionary ages at that moment in time. And so as the dictionary continues to get updated, this picture isn't going to get updated, okay? But the viewer does, okay? So this is like a, I don't know, do we still have like webcams, like traffic webcams? Does anybody even look at those things? Like those, like you can kind of, I don't know, there's like the, sometimes there's like a nest, a bird's nest, and then they have like the nature webcam that looks at the nest, and you're like, oh, I want to see if the eggs have hatched. I don't know. Okay. All right. So remember, this is the view object. Okay. View objects, like the dictionary, are unordered. So you can't index them. All right. You really can't do much with the view objects, actually. Okay. View objects, we just have list and length and in. So you can't say like, okay, what's the third item? That doesn't work. Okay. Ages are the values themselves. Okay. If you want a subset based on a key, use the dictionary. Okay. You can't reference the key in the view object of values, right? So ages are the values. There's no thing you get all these dictionary values is not subscriptable and things like that. Okay. The items themselves are basically a kind of almost like a list of tuples. Okay. But again, it's a view object. It's a view object. So it's not a list. Okay. You can force it into a list, but again, you have all of the same problems that you have when you take a picture of something. It's not going to update dynamically. But if you wanted to, you can, right? I'm trying to think like what advantage this would have. I can't think of anything. Let me think. I think, hold on. I'm curious now. So like for item in people.items, can I create let me just say print item. Is that going to work? Yeah, so that works. Okay, so view objects are iterable. So I can say, for value in people.values, and that will, you can do stuff with it, right? So you can do like print value times 10. Okay, and you can take people.values and you can iterate through them. Okay. And this is dynamic. So as people gets updated, this every time you run this, it will update as well. All right. So this is a little redundant because there's something called counter in Python, but I want to kind of just show you like this is how we can use a dictionary here, right? So let's say you have a string and you want to kind of go through and you want to count how many times does the letter A appear in the string, how many times does the letter B appear in the string, and things like that, okay? And so there's a couple ways we could do this, all right? Ways of thinking of solutions for just counting how many times each letter. You can have 26 variables, basically a variable for count, A count, B count, C count, D count, so on and so forth. You go through, you start them all off at 0. You go through the string of interest, and then every time you encounter a letter, you update the corresponding variable. Okay, but that requires 26 different variables in there. Okay, you can also create a list and kind of go by position, and you can say every time an A appears, let's update the first position. Anytime B appears, let's update the second position, so on and so forth. Okay, so you convert each character basically to a number using kind of the ORD function, which will basically put it in order, and then you use the number as an index on the list, and then appropriate thing. Okay, here we can also create a dictionary, and we'll use the characters as keys, and we'll have the counter of how many times that key appears or how many times that letter appeared as the value. Okay, first time we see character, we'll add it to the dictionary, and then after that we would kind of increment this. So here we're going to call this function histogram, but it's basically a letter counter, where we're going to start off with an empty dictionary, then we iterate through the string. Strings are iterable, where each item is a character, so we're going to go for every character in that string, and we're going to check, is that character in the dictionary? So we say if the character is not in D, then add it to the dictionary, and we're going to create a new entry in the dictionary by doing D character equals 1. Okay. Otherwise, that means if we do else, that means the character is in the dictionary, and then we're going to update it, right? We're going to do plus equals 1. We're just going to add 1 to the thing. right? So here we go. That's our function. We're going to call it on abracadabra, all right? And so again, it reads left to right, and it's going to go A. It's going to start off with A is 1, then it does B. B is 1. R, that doesn't exist. R is 1. A exists, so it's going to add 1 to that. And we're going to go through and we're going to count all of our letters. And at the end, we get A appears 5 times, B appears twice, R appears twice, C equals once, D equals once, right? And we can do, we can do histogram. What's the thing? She sells seashells by the seashore. I don't know, right? Is that not the tongue twister? All right, so we have that. And so again, reading kind of left to right, S-H-E, S appears 8 times and stuff like that. Okay. Once you have the dictionary, so H is my dictionary, A5, B2, R2, so on and so forth, you can iterate over the items in the dictionary. You can just say for key and H. When you do a for loop with the dictionary, it's going to kind of go through the thing. Now, I told you Python dictionaries are not ordered, and that is true. You're not allowed to kind of reference things, but there is, like when you run a for loop, there's going to be an order of things, okay? And the order of things is going to be basically like when you pull things out of your backpack, there's going to be an order of things in which the things come out of your backpack, okay? And so when Python kind of iterates over a dictionary, it just kind of goes, it's going to just be in the order that it appears here, okay? Even though we don't like to say like, oh, what's the 4th entry, okay? It will kind of appear in this order. So so as far as the abracadabra, it's going to go A, B, R, C, D, okay? And we can just, here I'm just saying print the key along with the value associated with the key, okay? And so it goes through and it prints that out, okay? Now, you can also, right, you can run sorted on the dictionary, okay? And it basically takes, it's like it dumps out the items in your backpack, and then it says, okay, we're gonna sort these, and then we'll go through them, okay? And so here we can also do sorted, and it will take the keys and put them in alphabetical order, or whatever order it's able to do, okay? So if you have, I haven't tried this, but let's try this, okay? So I'm gonna create a new dictionary, and I'm gonna put A as a key, and B as a key. All right, let's put this in different order. We'll put B first, then A, and then I'm going to put the number. Hello. Okay. And I think so. I can do for key in H3, and we'll say print the key and whatever the value is associated with that key. All right, so that works there. I don't think I can do sorted because I think sorted is going to complain. I don't know how to alphabetize integers and things. Yeah, so it says, because what it does is it basically dumps out the keys here, and it says, so if I say h3 dot keys, we get this, and I don't think I can do so I can't do. I don't know if I don't even know if I can do this with a regular thing. Okay, no, I can. Okay, so if I have h dot keys gives me this, and I can put it inside sorted, and then I get back a list that has been sorted. Right, so what's the type on this? This is no longer a view object. This is a list. Okay, so Python kind of does things on the fly for you, right? So dictionary keys, if I say what's the type on this, this is not a list, it's a dictionary keys object, okay? All right, but yeah, if you try to do sorted and you have like mixed key types, it's not gonna work. Okay, all right. so dictionaries are designed to return values when you provide the key. If you need to find the key associated with a particular value, it's harder, and we have to perform a search. And so this is reverse lookup dictionary, where basically we are going to, and this is really slow. Okay. You take the dictionary, you take the value you're searching for, then we have to kind of iterate through every item in the dictionary. For each key in the dictionary, we're going to just check if the dictionary, if the value with that key is associated with the value. And if it is, we'll return the key. And if not, we'll raise an error that says the value doesn't appear in the dictionary, okay? Raise and lookup error, this is kind of just like, you know, print a message out to the user, but raise will not just print the message, it will appear as an error, right? So errors, as you're running code, and when you encounter an error, it actually stops the running of any of the remaining code, okay? So raise will do this. You can look up help on raise, and there's a whole bunch of different types of errors. So you can say there's a key error, a name error, a lookup error, whatever. And these are all kind of intended for the end user to have a better idea of what's causing the error. Like you could be mean and you can say this is a name error, okay? But that will just confuse the user, okay? There's nothing like inherently in Python that's like, oh, the error has to be this, okay? This is like you are picking, oh, when this happens, this is this type of error. Okay, so anyway, here's our dictionary for abracadabra. We're gonna look up, there's 2 up here, okay? And it reads left to right. Again, we don't like to say dictionaries are ordered, but there is like, when you dump things out of your backpack, there is an order in which they come out. And so it's gonna kind of give us the first thing that it encounters, which will be the B. If we say, hey, is there anything with a 4? We don't find that, okay? Value doesn't appear in the dictionary. Okay, and I have a little bit more on the raise statement about the different kinds of exceptions. And here's an entry where I tried to create a dictionary where the values are lists, okay? And this is going to be an inverse dictionary. So back here, basically, it's like when I did a reverse lookup on 2, I only got B back. But what if I wanted B and R back? Okay, and if I said reverse lookup on 1, what if I want C and D back? I want all of the things that have only a 1 or a 2 or something like that. And so you can kind of parse through this code on your own and see if you understand it. But this is basically a thing where I tried to create the inverse dictionary. Okay, so here I have the dictionary H, where I'm going to do this, and then here I'm going to call invert the dictionary, and we're going to take all of the 1s and create a list of all of the keys associated with the 1 and everything else. And so we have 1 is associated, you know, P, A, O, and T, and 2 gives me an R. Let me see if I can invert. I think H2 was seashells. Okay, so we have this and stuff. So this is kind of like, these are all the letters that appeared, you know, once and stuff or whatever. Okay, so this is the invert dictionary, and you can read through it. Okay, let me give you your third answer today, and that is the letter A. A as in apple is your third answer. Is that right? Did I mess something up? Okay. Okay, and that's it. All right. Have a great rest of your day.